right, let's look at this concept of if the base of the log and the base of the argument is the same, what happens? Well, something special happens here, and that is that the exponent for the argument becomes the answer. It's almost like this log base b and this base b cancel each other out, and you're just left with the exponent, okay? Really quickly, let's look at some of these examples. So again, if the bases are the same, the answer is the exponent. So here we are not converting forms. We actually want to simplify these logs. So we want to answer. We have a log base of 6 and our argument is 6 to the 8th. So this log of 6 and this base of 6 here in the argument all kind of cancel out, and my answer is just 8. Okay, we like these problems, I know. Here, log base 2 of 2 to the 5th. So log base 2 and this 2 will cancel, and 5 ends up being the answer. What about C? We just have log of 10 squared. So remember, log with no base that we can see is an understood base 10. That's our common log. So these do still have the same base. So that means our answer is just the exponent of 2. And then looking at D, we've got natural log of e to the 3rd. Remember that natural log is log base e. So this will be log base e of e to the 3rd. We have the same bases, so our answer is just the exponent of 3. All right, looking at our next set here, we want to find the logarithms, but we do want the actual answer, and we are going to rewrite the argument. So that means we need to rewrite this to have the same base as the log. Looking at log base 6 of 36, we have log base 6 of 6 to what power? This is what you have to figure out. So you're taking your calculator and you're going to do 6 times 6 and see if that gives you 36. In this case, it does. So how many 6s did you multiply together? 2. So this is really log base 6 of 6 squared, because 6 squared is 36. Now we have bases that are the same, and our answer is just 2. Looking at our next one, log base 10 of 1,000. This is going to be log base 10 of 10 to what power? So again, start by doing 10 times 10. It's the base here that you're using to figure out what this, or how many times you multiply it together to get the 1,000, okay? So obviously 10 times 10 is just going to be 100, but if I multiply by another 10, I'm going to get that 1,000. How many 10s do I have? 1, 2, 3. So this is going to be 10 to the 3rd, and now our bases are the same, and our answer is 3. Let's look at the next one, log base 6 of 216. So we want this to be log base 6 of 6 to something. So 6 times 6 is 36. But if we multiply by 6 again, we get the 216. So how many 6s was that? It was 3 of them. So again, now we have our bases the same, and our exponent is the answer. And then looking at log base 7 of 1. This one's kind of tricky. Log base 7 of 7 to what power? So how many times do you multiply 7 together to get 1? I'll let you think for a minute. How many times do you multiply 7 together to get 1? Well, 7 times 7 is 49, so that's not going to be it. And 7 by itself is just 7. So this one is kind of a key mathematical concept. The answer is just 0. Remember, anything, a to the 0 power, anything raised to the 0 power is 1. So the answer here is just our exponent of 0. Okay? So if you see this as simplify or evaluate for any log, see if you can change the argument to have the same base as the log, and then you can use this concept.